Find the area of the triangle with vertices, la la la. Okay. Well, the way we normally find the area of a triangle is with the formula area equals 1/2 base times height, but they haven't given us any measurements for bases or heights, so we're going to have to do something clever with these coordinates. Let's get these plotted first and see what this triangle looks like. If we have a vertex at -3, -2, and we have a vertex at 1, -5, and we have a vertex at 6, 10 up here, then our triangle goes like that, and oh, that line's not so good. Let me try that again. Side like that, side like that. Okay, and we'll get the coordinates in on there because we're certainly going to need them. 1, -5, -3, -2, and 6, 10. Okay. Well, the base and the height of a triangle have to be perpendicular, meaning they have to be at right angles to each other. And it looks like that might be the case with these two sides. Maybe we can use this left side as our height, and this side down here as our base. Are they perpendicular though? Better make sure. The slope of our height is, you remember, y2 minus y1 over x2 minus x1. It should be 10 minus -2 over 6 minus -3, which cleans up to 4/3. I'm doing this a little bit condensed because we practiced a lot of slopes. I trust you're getting comfortable with them by now. The slope for our base is -5 minus -2 over 1 minus -3. Are those perpendicular? Yep, they are. Each of these slopes is the negative reciprocal of the other one, or the other test you could do is multiply these two slopes and you get -12 over 12, which is -1. And that's the other thing that perpendicular slopes do. Their product is always -1. So yes, these two lines are at right angles to each other. We could use them as our base and height. So the area is 1/2 times the length of the base times the length of the height. We need some lengths. We need the distance formula, and we need to do it twice. For our base, the length of the base, meaning the distance from one end of it to the other, is x2 minus x1 all squared, y2 minus y1 all squared. Or if you're used to a formula that has 1 minus 2's, that's fine. The order doesn't matter when you're doing this. If you have the order backwards, what happens is this number will come out with a negative sign on it, but the fact that we're squaring it means that negative sign can't hurt us, so you can do these in whatever order you like, essentially. For the x's, we do 1 minus -3 squared. And for the y's, we get -5 minus -2, which is -3 squared. That comes out to 16 plus 9 is √25, which is, our base is 5. Good. Now we do the same thing for the height. The height is going to be the square root of, same thing again, from this corner to this corner. For x's, we have 6 minus -3. And for y's, we have 10 minus -2. That's the square root of 9 squared is 81, 12 squared is 144. Add those up, you get the square root of 225, which is 15. So now we're ready to do area. The area of this triangle is 1/2 base times height. So it's 1/2. The base is 5. The height is 15. 5 times 15 is 75. Half of that is 37.5. And we didn't mention units, so I'm just going to say square units.